Hurricanes, Earth's Mightiest Storm by Patricia Lauber. The making of a hurricane. Great whirling storms roar out of the oceans in many parts of the world. They are called by several names. Hurricane, typhoon, and cyclone are the three most familiar ones. But no matter what they are called, they are all the same sort of the storms. They are born the same way, in tropical waters. They develop the same way, feeding on warm, moist air. And they do the same kind of damage, both ashore and at sea. Other storms may cover a bigger area or have higher winds, but none can match both the size and the fury of hurricanes. They are Earth's mightiest storms. Like all storms, they take place in the atmosphere, the envelope of air that surrounds the Earth and presses on its surface. The pressure at any one place is always changing. There are days when air is sinking and the atmosphere presses harder on the surface. These are times of high pressure. There are days when a lot of air is rising and the atmosphere does not press down as hard. These are times of low pressure. Low pressure areas over warm oceans give birth to hurricanes. No one knows exactly what happens to start these storms, but when conditions are right, warm, moist air is set in motion. It begins to rise rapidly from the surface of the ocean in a low pressure area, like water in a hose. Air flows from where there is more pressure to where there is less pressure. And so air over the surface of the ocean flows into the low pressure area, picking up moisture as it travels. This warm, moist air soars upward. As the air rises above the earth, it cools. The cooling causes moisture to condense into tiny droplets of water that form clouds. As the moisture condenses, it gives off heat. Heat is one kind of energy. It is the energy that powers the storm. The clouds are the source of the storm's rain. Warm ocean surface. Birth of a hurricane, warm, moist air flows into a low-pressure area. As the air rises and condenses into clouds, more warm air is drawn over the surface of the ocean. It spirals upwards, traveling counterclockwise. Clusters of thunderstorms form. The low-pressure area acts like a chimney. Warm air is drawn in at the bottom, rises in a column, cools and spreads out. As the air inside rises and more air is drawn in, the storm grows. The air being drawn in, however, does not travel in a straight line. The Earth's surface is rotating, and the rotations cause the path to curve. The air travels in a spiral within the storm. In the northern hemisphere, the spiraling winds travel counterclockwise, the opposite of the way the hands on the clock move. In the southern hemispheres, they travel clockwise. Most of these storms die out within hours or days of their birth. Only about 1 out of 10 grows into a hurricane. Inside a hurricane, high wind spirals around the eye, but within the eye all is calm. Air pressure within the eye is extremely low. Because there is less pressure on it than on surrounding areas, the sea under the hurricanes rises in a bulge or dome. Some weather instruments. Ancient people lived through great storms. They looked for signs that would help them predict the weather. They tried to explain the weather they experienced, but no one can really study weather without measuring what is happening. The instruments to make such measurements were invented 300 to 400 years ago. Modern versions of them are still used today. Barometer. Barometer measures air pressures. Rising air pressure tells of fair weather, while falling air pressure tells of stormy weather. This kind of barometer is often seen in homes and schools. Hygrometer. Hygrometer measures the amount of moisture in the air, the humidity. Warm air can hold more moisture or water vapor than cool or cold air. When warm, most air is cooled. Water vapor condenses, changed from a gas to a liquid. That is why a glass of ice-cold soda seems to sweat in the summer. Warm air around the glass is chilled and water vapor condenses out of it onto the glass. Anemometer. An anemometer measures wind speed. The rate at which its blades spin outdoors is registered on a dial indoors. In the 1938 hurricane and other violent storms, anemometers have blown away, making it hard to tell what the highest wind speed were. Thermometer. A thermometer measures temperature. Word names. In the Caribbean Sea and North Atlantic, Earth's mightiest storms are called hurricanes, after a Caribbean word for big wind. In the Pacific, they are also called hurricanes if they occur east of the international date line. West of the date line, they are called typhoons, from Chinese words for great wind. In the Indian Ocean, they are called cyclones, an English name based on a Greek word meaning coil, as in coil of a snake. Because of the winds that swirl within them, the storms also have a number of local names. Many Australians, for example, call the Willy Willies. The name probably began a whirlwind, which became Whirly Whirly, which became Willy Willy. Earth's mightiest storms take shape over tropical waters. All move westward at first, then either die out over land or turn eastward, losing power over cooler oceans waters. For some reason, these storms do not form in the South Atlantic or Southeast Pacific Oceans. Into the eye of the storm. Today, rugged plains carry many instruments into hurricanes as they near land. The instruments measure winds, temperatures, and humidity. They measure the water content of clouds. They photograph the inside of hurricanes. They record radar images of the storms. In April 1960, the first weather satellite rocked into orbit. Now, scientists hoped to find and track tropical storms before they neared land. They were rewarded almost at once. A few days after its launching, the satellite discovered a typhoon in the South Pacific. Satellite instruments do not see to the heart of a hurricane. That work is still done by planes. Satellites show the size of the storm and its growth. They show changes in the size of the eye. If the eye is growing bigger, the storm is weakening. If it's growing smaller, the storm is strengthening. Most important, satellites can pinpoint the location of storm, record its speeds, and track it closely. Information from ground stations and ships, from hurricane hunting planes and satellites, forecasters have more information than the human mind can grasp. But since the 1960s, they have been able to feed all this information into computers. Now they can create computer models of hurricanes. They can compare a hurricane with similar ones that occurred years earlier. Forecasting just one storm may involve several million bits of data and several billion mathematical calculations. Huge computers do the work. Today, no one who reads a newspaper, listens to radio, or watches television can be taken by surprise when a hurricane strikes. Although forecasters cannot say exactly where a hurricane will come ashore, they do know which areas will feel the storm. They can warn people in its path, as they did with Andrew in summer 1992. This satellite image shows Tropical Storm Dolly on July 21, 2008.